Successive differentiation. Exercise 5.7. Successive differentiation. Successive differentiation. What does mean successive differentiation? Given y or f of x. Given y equal to f of x. If we differentiate once dy with respect to x, we will get dy by dx. This can be rewritten as dy by dx means it is y1. It is also known as y1. dy by dx, it is also known as y1. That is equal to f dash of x. These all three represents the first derivative. Now, differentiating dy by dx with respect to x, that is d by dx of dy by dx. Differentiation of the first derivative is d by dx of dy by dx, that is known as d square y by dx square. It is also denoted by y2 or f double dash of x. F1 dash means first derivative. F double dash means it is second derivative. Second derivative means successive differentiation. After finding first derivative, differentiating the first derivative with respect to the same variable, will get a second derivative f double dash of x. So this is y. First derivative is dy by dx. Its second derivative is d square y by dx square. It is performed differentiating dy by dx with respect to dx again. Now, again differentiating this d square y by dx square with respect to x, we will get d cube y by dx cube. This is known as third derivative. It is also known as y3. That will be equal to f triple dash of x. Similarly, we can proceed till the function get a 0, become 0. The derivative becomes 0. We can differentiate according to the function, the number of times required. So, these type of successive differentiation is known as successive differentiation. The repeated differentiation of a given function is known as successive differentiation. So this is known as first derivative. This is known as first derivative. And this one is known as second derivative. It will be given in any of these three forms, d square by dx square, y2 or f double dash of 2. These all three represents second derivative. And this is known as third derivative. This type of case is known as third derivative. So differentiating the function, given function again and again, after completing first, again differentiating first derivative, will get second. After completing second, again differentiating the result, will get third derivative. This type of continuous derivative is known as successive differentiation. Now we have some simple problems in our exercise 5.7 to find the successive differentials. The problem 1 is find the second derivative. Find second derivative given second derivative of x square plus 3x plus 2. This is very simple to calculate. Let y equal to the given function x square plus 3x plus 2. Here we have variable in x, so differentiate with respect to x. Differentiating with respect to x, we can get derivative of y with respect to x is dy by dx, which is equal to derivative of x square is, by use of the formula, n into x power n. Derivative of x power n, d by dx of x power n equal to n into x to the power n minus 1. So x square is 2x power 2 minus 1, so that is 2x. Now 3 into derivative of x with respect to x is 1 and the constant is 0. So dy by dx is equal to 2x plus 3. Here again differentiating the result with respect to x. Here the derivative of dy by dx with respect to x is d square y by dx square. That means d by dx of dy by dx. d by dx of dy by dx, that is d square y by dx square. Again differentiating the right side here, 2 into derivative of x is 1, the constant is 0, that is equal to 2. Therefore the respective second derivative is d square y by dx square, that is equal to 2. This is question number 1. And for the question number 2, given find the second derivative of, find d square y by dx square, or y2 will be given. Find the second derivative or d square by dx square or y2. They will be given, the question will be given in any of the form, either d square by dx square or y2 or second derivative in word. All are representing the similar meaning. So same meaning. So now d square by dx square or y2. Given y equal to x to the power 20. X to the power 20. Now the first derivative is differentiation with respect to x. Differentiate with respect to x now. dy by dx is equal to, by use of the exponent formula, 20 x to the power 20 minus 1, that is equal to 20 x to the power 19. Now again differentiating with respect to x. This is the first derivative, we need the second derivative. So again differentiating with respect to x, we can get d square y by dx square equal to 20 into 19 x to the power 19 minus 1, which will be equal to 20 into 19. Here I can write here, which is equal to 20 into 19, 380 x to the power 19 minus 1 is 80. So 380 x to the power 18 is the second derivative of x to the power 20. Question number 3. Find the second derivative of x cos x. Given x cos x. I have taken let y equal to x cos x. Differentiating with respect to x. Y with respect to x is dy by dx, that is equal to, here there are two functions, they are in product. The functions appears in product, we should use product rule of the derivative, u dash v plus uv dash. So u equal to x and v equal to cos x. U dash is equal to 1 because x with respect to x is 1, and v dash is equal to derivative of cos x is minus sin x. By formula u dash v uv dash, just cross multiply, minus x sin x uv dash or u dash v, you can write any of the way, there is addition in between them, we can interchange the steps, it will not be terms, it will not be affect your answer. So you can cross multiply now, just minus x sin x or 1 into cos x and then plus of minus x sin x. Multiplying u dash v and uv dash. U dash into v is 1 into cos x, u into v dash is x into minus sin x sin x. This is dy by dx. So which is equal to cos x minus x sin x. That is dy by dx. We have completed the first derivative. We need the second derivative. This means again differentiating the result with respect to x. We can get dy by dx is d square by dx square. Again differentiating dy by dx now, we will get d square by dx square. This is the second derivative. And derivative of cos x is minus sin x. And then minus of, here we have two functions. One is u, that is x. Another one is v, that is sin x. Now u dash is equal to 1 because differentiation takes place with respect to x. And v dash is equal to derivative of sin x is cos x. Now uv dash plus u dash v. And here we have sin x plus x cos x. Again substituting the same formula, we can get a minus sin x plus x cos x. Multiply minus inside, we will get minus sin x, again minus sin x, minus x cos x. Simplifying these two, we will get d square by dx square equal to minus 2 sin x minus x cos x. So the second derivative of the given function x cos x is minus 2 sin x minus x cos x. We couldn't take anything common between the two terms, so simply we can leave it, or we can remove minus as common and we can write one more step here, minus of 2 sin x plus x cos x, or we can leave here itself, we will get the mark. Now we are moving to question number 4. The question number 4 is simple thing, y equal to log x simply given. Given y equal to log x, and its first derivative dy by dx is equal to derivative of log x is 1 by x. And then again differentiating with respect to x, dy by dx is d square by x dx square, which is equal to derivative of 1 by x is minus 1 by x square. Simple thing. Or we can use a 1 by x power n formula. Anyway, we will get directly, you should know derivative of 1 by x is minus 1 by x square. That is better to apply. So that's all we have completed. It's a second derivative value. This is very simple problem. Now we are moving to question number 5. The question number 5 is similar to question number 3. But given question number 5, y equal to x cube log x is given. X cube log x is given. Differentiate with respect to x. dy by dx is equal to. There are two functions, they are in product. So it should be u equal to x cube and v equal to log x. U equal to x cube and v equal to log x. U dash, that is 3x square. By use of x power n formula, u dash is 3x square. And then v dash, derivative of log x is 1 by x. By formula, we have d of uv, derivative of uv equal to u dash v plus uv dash. Now u dash into v, 3x square into log x plus uv dash, u into v dash means x cube into 1 by x. Simplify this, we will get x square. Cancelling this x cube and x will get x square. So dy by dx is equal to, we can take out x square as common. So x square into 3 log x plus 1. Removing x square as common, we can get x square removed, remaining is 3 log x in the first term. And here we have only x square, that is removed, remaining is 1. Now we need to find d square by dx square. For that I am differentiating again with respect to, differentiate with respect to the same variable x. And here we have u equal to x square, d square y by dx square. Derivative of dy by dx with respect to x is d square by dx square. Now here we have two terms, one is u, another one is v. U equal to x square, so u dash is equal to 2x, and v equal to 3 log x plus 1. We have v equal to 3 log x plus 1, which implies v dash is equal to 3 into derivative of log x is 1 by x, and derivative of constant is 0. So simply we have v dash is 3 by x. Substituting in the formula, u dash v, multiplying u dash into v, u dash is x square, v is 3 log x plus 1. So x square into 3 log x plus 1. We have completed u dash v. Now plus u v dash plus u into v dash. U is x square. Now u dash v, sorry. Here u dash v means u dash is 2x. So u dash into v, this means 2x into 3 log x plus 1. Now we have completed u dash v, and then we are moving to u v dash. U into v dash means multiplying these two, x square into 3 by x, that is x square into 3 by x. Now x and x square get cancelled. Here we have remaining x. This means 2x into 3 log x plus 1 plus x. Here Cancelling x square and x, we will get remaining only x into 3. This means it is 3x we can have. So remaining is 3x. So we can take out 3x as common here. We can take out 3x as common. We can take out 3x as common, or we can leave this step. We will get the answer. Question number 6. Given y equal to e power x into sin 5x. Y equal to e power x into sin 5x. Here we need to find a second derivative of the given function. U equal to e power x and v equal to sin 5x. Two functions, they are in product. We should apply a product rule of differentiation. D of uv equal to u dash v plus uv dash, or u v dash plus u dash v. We can interchange the steps because we have plus in between them. We need u dash and v dash. Differentiation of u with respect to x is u dash. Derivative of e power x is e power x. And derivative of v with respect to x. Derivative of sin ax, d by dx of sin ax is equal to a cos ax. So it implies 5 cos 5x. Substitute here. So differentiate with respect to x. We can have dy by dx is equal to uv dash plus u dash v, or u dash v plus uv dash, multiplying these two, e power x into sin 5x plus e power x into 5 cos 5x. And taking out a common e power x, dy by dx is equal to e to the power x into sin 5x plus 5 cos 5x. And then we need to differentiate it again because we need second derivative. Again differentiating with respect to x. Again differentiating with respect to x. The derivative of dy by dx is d square y by dx square. That is equal to here. There are functions, they are in addition, so this is totally taken as one function, and e power x is another function because e power x into sin 5x plus 5 cos 5x is given. So these two are in product. So u equal to e power x and v equal to fully taken v, that is sin 5x plus 5 cos 5x. Here u dash is equal to derivative of e power x is e power x, and v dash is equal to derivative of sin 5x. D by dx of sin ax is a cos ax. This means 5 cos 5x, and then plus 5 into derivative of cos ax, that is equal to minus a sin ax. By use of it, minus 5 sin 5x should be equal to 5 cos 5x minus 25 sin 5x is the derivative of v. Now substituting in the above formula, u dash v plus uv dash, u dash into v, multiplying these two, e power x into sin 5x plus 5 cos 5x plus u dash v we have completed, u dash into v. Now multiplying u into v dash, simplified answer of v dash into u, e power x into, within the bracket, v dash, we have e power x into u into v dash is 5 cos 5x minus 25 sin 5x. We can take out e power x as common. We can get d square y by dx square equal to, taking e power x as common, sin 5x and minus 25 sin 5x. Totally minus 25 plus 1 is minus 24 sin 5x, and then adding these two, 5 cos x plus 5 cos x plus 10 cos 5x. Look at here, when we when we took e power x common, when we take e power x as common, The remaining are sin 5x, 5 cos 5x, 5 cos 5x minus 25 sin 5x. These two are equal terms. Minus 25 plus 1 is minus 24 sin 5x, and these two are also equal, but 5 plus 5 10 cos 5x. Simplifying we will get this answer. This is our required second derivative of the given function y equal to e power x into sin 5x. Question number 7, similar to question number 6, you can complete because e power 6x is given. Derivative of e power 6x is 6 e power 6x, and cos 3x, derivative of cos 3x is minus 3 sin 3x. Now we are in question number 8, given y equal tan inverse x. Here also we need the second derivative of the given function y. So differentiate with respect to x. dy by dx is equal to derivative of tan inverse x is 1 by 1 plus x square. Now we should differentiate it again. Differentiate again with respect to x. Here we can simplify it as 1 plus x square whole power minus 1 for our convenience. Now differentiating, derivative of dy by dx with respect to x is d square y by dx square, which is equal to, now applying exponent formula, here chain rule will be applied. First apply exponent formula, that is minus 1 plus x square whole power minus 1 n x power n minus 1 into, then differentiate the function within the power, that is 1 plus x square is 0 plus 2x, which is equal to minus 1 into 2x is minus 2x into 1 plus x square whole power minus 2, which is equal to minus 2x divided by 1 plus x square whole power plus 2. This is known as d square y by dx square. Either you can directly go with this step, that is d square y by dx square equal to, or alternatively this is the form of 1 by x. So derivative of 1 by x is minus 1 by x square. Instead x we have 1 plus x square. So derivative of 1 by x is minus 1 by x square. Instead x we have 1 plus x square. So 1 by 1 plus x square whole square minus 1 by 1 plus x square whole square. And then differentiating the function appeared instead x, that is 1 plus x square. Differentiating 1 plus x square will get 0 plus 2x. And multiply it will get minus 2x by 1 plus x square whole square. So both the way will get the same answer. So you should apply any of the way which is easy to you. Now question number 8 we have completed, and moving to question number 9, that is given as y equal to log x. Question number 9, y equal to log x is given. Y equal to log x. Here is a function of function is given. A function within a function is given. So dy by dx is equal to, differentiate with respect to x, dy by dx is equal to, first of all this is taken as x. The derivative of log x is 1 by x. So 1 by log x into, again differentiating this log x, multiply with this function 1 by x. When we take this log x is x, so 1 by x is 1 by log x. Now moving to the second function log x, this is derivative of log x is 1 by x. So the derivative of y equal to log x is 1 by x log x. 1 by x log x. Now we can modify it 1 by x by log x. We can change it as 1 by x by log x, and then we can use u by v formula, or Okay, now this is equal to 1 by x divided by log x. Okay, reciprocally to 1 by x log x will come. Now again differentiating with respect to x. Again differentiating with respect to x. dy by dx, derivative of dy by dx is d square by dx square. Here we have u equal to 1 by x and v equal to log x. U dash is equal to derivative of 1 by x minus 1 by x square. V dash is equal to derivative of log x is 1 by x. Now, by using u by v formula, derivative of u by v equal to v square v into u dash minus u into v dash. Substituting in it, we have v square. V is log x, so log x whole square. V into log x into u dash is minus 1 by x square by formula minus u into u is 1 by x into v dash is also 1 by x. So simplify it, will get log x whole square. Now minus 1 by x square into minus 1 by x square. Here we have minus 1 by x square, here also we have minus 1 by x square. Taken out minus 1 by x square, minus 1 by x square into remaining is log x plus 1. Log x plus 1. So this is our d square by dx square. That is the required second derivative of the function y equal to log of log x. For first derivative it will be 1 by x log x. For our convenience we can simplify it as 1 by x divided by log x. Now reciprocally we will get 1 by x log x. So this is taken as u, this is taken as v. So this is in the form of u by v, derivative of u by v form. So u and v separately taken and differentiated with respect to x. We have got u dash and v dash. Substituting in the formula d of u by v, v into u dash minus u into v dash by v square. Here you need not to interchange this terms. Perfectly you should apply in the particular form v into u dash minus u into v dash, because we have subtraction between these terms, between the terms. If addition appears between the terms, you can interchange the terms, it will not be a problem to us. Suppose subtraction appears, you need not to interchange the steps. So the particular order of vu dash minus uv dash you should substitute. So substituting, simplify, will get minus 1 by x square into log x plus 1 divided by log x whole square. That is d square by dx square, second derivative of the given function. Question number 10, y equal to sine of log x. We need to find a second derivative of the given function. So differentiate with respect to x. dy by dx is equal to, here function of function appears, we should apply chain rule. First of all we should differentiate sin x, then we are going to log x. So derivative of sin x is cos x, instead x we have log x. So this is sin x, its differentiation is cos x. And then differentiating the log x within the bracket, we will get 1 by x. So which is equal to cos of log x divided by x. Now again we need to differentiate it because we need second derivative. Again differentiating with respect to x, we have d square y by dx square equal to u is cos of log x, u dash is equal to, for cos of log x, it is minus sin of log x into derivative of log x is 1 by x. So it will be equal to minus sin of log x divided by x. And then now moving to v. V is x, or you can write here v equal to x and v dash is equal to 1. Substituting in the formula, derivative of u by v equal to v square v into u dash minus u into v dash Substitute here b square x square. b is x, b square x square. b into u dash. b is x, u dash is minus sine of log x into 1 by x minus u into v dash cos of log x into 1. This x and x get cancelled. Remaining is minus sine of log x minus cos of log x divided by x square. We can remove minus as common. That is our required second derivative, d square by dx square. Remove minus as common. It will be minus of sine of log x plus cos of log x divided by x square. Question number 11, find the second derivative and prove that d square by dx square plus y equal to 0. Given y equal to 5 cos x minus 3 sin x. Differentiate with respect to x. dy by dx is equal to 5 constant. Derivative of cos x is minus sin x. And minus 3 into derivative of sin x is cos x. So simplify it, minus 5 sin x minus 3 cos x. They are individual different terms, we can directly differentiate. There are two functions, they are separated by subtraction. So we should differentiate consecutively the given functions. We need not apply product rule or chain rule and all, because this is separate function, this is separate function. The functions are separated by addition and subtraction, we can directly differentiate. So here 5 into cos x minus sin x minus 3 into sin x is cos x. When we simplify, minus sin x minus 5 sin x minus 3 cos x. Now again differentiate with respect to x. Again differentiate with respect to x. d square y by dx square, that is a derivative of dy by dx, is equal to minus 5 constant, that is in product, so keep the same, and sin x, derivative of sin x is cos x, and minus 3 into derivative of cos x is minus sin x, and then simplify it, will get d square y by dx square equal to minus 5 cos x plus 3 sin x. This is our second derivative, but we need to prove d square by dx square plus y equal to 0. Look at the problem here. It is 5 cos x minus 3 sin x. Here we have minus 5 cos x plus 3 sin x. Taking minus as common, d square y by dx square equal to minus of 5 cos x plus 3 sin x. Substituting 5 cos x plus 3 sin x, 5 cos x minus 3 sin x, because minus is taken out, it become plus, second term become minus. Now 5 cos x minus 3 sin x is y. Substituting here, d square by dx square equal to minus y, because totally taken as y given problem. Now bringing to the left side, d square by dx square plus y equal to 0. Thus we have proved it, d square by dx square plus y equal to 0.